We are back with Chief Scientist Carl, the Imagination Station in Toledo. What are we going to blow up this morning, Carl?
Well, a little bit later we're going to set some things on fire, but right now we're going to talk polymers. Okay, chemistry of polymers. And I just need to do one thing to get ready here. I need to add some water to this
Tell
glass.
the folks at home what a polymer is.
A polymer is a long chain molecule. It's really, really long and has many identical repeating units. Okay, think of a chain. Okay. That would be a polymer.
All right, and you can use different molecules as polymers, right?
You can. Different monomers could be chained together to make up polymers. You can cross-link the polymers. And in fact, we're going to talk about that. But first, if you could carefully balance that cup of water there. I don't want to make too much of a mess here, but I do need the card back.
What?
This is a polymer, man. This is the polymer that you find in diapers. Sodium polyacrylate. So I added just a little bit of dry powder.
And it's safe.
It is totally safe. It's just, we're wearing gloves because it gets kind of messy here.
Okay.
So this stuff is really cool. It can absorb up to 800 times its weight in water. In fact, here, let me show you this. It is so cool how fast this happens. I've got 16 ounces of water here. I want you to count with me as we pour this into this cup, all right? Okay. So we go 1, 2, 3, 4, and
get out of
gelled
town.
up. All right?
That's cool.
Is that not cool? Now, of course, this is not what you want to have happen inside a diaper, right? If this happened inside a diaper, here, let me give you this.
Oh, thanks. Yeah. Talking about a diaper and you hand me a clop like
Okay, well, come on over here to the tray here so we don't get too messy. And if this happened in a diaper, the first squirt would do this, the second squirt would squirt right out the sides.
Okay, gotcha.
Right? But now, we have not even tapped into the potential of this polymer here. I'm going to add some more water to it, and some more water to it. And a little bit more. Hold it over the tray so it won't get too messy. But you can see the polymer continues to absorb water. Okay? It can absorb, like I said, up to 800 times its weight in water. And it does that because it has something inside of it called sodium. It's got sodium ions inside.
All right.
You're going to keep, okay, let's add some more here. We can really load this up. We can reverse this process, though, this absorption process, by adding a lot of salt on the outside. If we had an excess of sodium on the outside, we can reverse that osmotic process that locked the water inside. And you're going to start to see this is going to start to fall apart in your hands pretty quick here. Give it a little squish for me.
Oh, yeah. Okay.
Is it falling apart?
Yep.
That's why we got the gloves on, because it's going to make a huge mess here. And this is a problem for people that design diapers, because urine is a 10% solution of sodium.
All right.
So while this stuff can, just go and drop the whole thing, it's getting really messy here. This stuff can hold 800 times its weight in distilled water, but in urine, only about 40 times its weight. Now, if you take this same stuff, come on down here. This is even better. If you take this same stuff, the sodium polyacrylate, and you process it a little bit differently, you cross-link it a little bit differently, you can make these tiny little granules like this that will start to absorb water. And they can actually absorb up to 200 times their volume in water. And they won't stick together like that goop that's on your hands. What we can do, though, is add some water here to these containers. I've got just a little bit of something we call instant snow. This is really cool. Let me show you the technique, because you're going to pour some of your water into this beaker as well. But we want to get good mixing so the polymer can hydrate. So we do this. Watch what happens. Go ahead and do yours.
Okay.
Excellent. Oh, that's perfect. We're going to start to see this stuff swell up as it begins to hydrate, and we're going to end up with, go ahead and grab your beaker here. Let's see how much volume of snow we can actually generate on the table here. Your stage people are going to love this. Okay, we started with this much powder, and now we ended up with this much snow. This stuff is actually used on movie sets. And it has such a nice feel to it. Stick your hands in
it. The volume is like 20 times what it was?
It's like 200 times the volume.
Someone call Pfizer.
So this is just some of the cool stuff we do down at the Science Center. If you want to check out polymer chemistry, explosions, all sorts of really cool stuff, come on down to the Imagination Station in Toledo, Ohio. Stuff we do every day.
What are we going to blow up next hour?
We're going to talk about Christmas trees and how they can actually be kind of dangerous if they get too dry.
All right.
It's going to be kind of cool.
And frostology, the science of the season?
Science of the season, we do all sorts of really cool stuff with ice, liquid nitrogen ice cream, all sorts of things with snowflakes, really cool stuff down at the Science Center.
All right, Chief Scientist Carl is going to hang around, and we'll have more fun with the Imagination Station.